Redis is one of those tools that is used in so many places because it solves so many problems. So learning even the basics of Redis is a core part of becoming a well-rounded engineer. And in this video, I'm going to show you just enough Redis for you to be productive. I want to show you just enough Redis so you can take it and you can start using it in your own projects and eventually use it in a production project. So by watching this video, what are you going to learn? You're going to learn what Redis is, and you might already have an idea of what Redis is. You might already know that it's a key value store, but I'm going to show you that Redis is actually much more than that. You're going to start to realize why Redis is so popular. You're going to learn how to use Redis via the command line, and we're going to go through some samples of how to use Redis in Node.js to solve some really common problems. So to get the most out of this video, I recommend that you go to the description below and you clone the repository that I've supplied there. And then in that repository, you're going to find some files that you can use to follow along with this video. And to do that, you're going to need Node.js installed. And I thought to myself, what's the easiest way for someone to get up and running with Redis? And the answer to that is obviously Upstash. So I reached out to Upstash to sponsor this video and they kindly agreed. So if you click on the link to Upstash in either the README of this repository or in the description below, you're going to be able to sign up to a free account and then you're going to be able to follow along inside of the Redis terminal. So what is the structure of this video? Well, this video is going to be very interactive. And again, I really want you to follow along with what it is that we're working on here because we're going to be solving some real problems and I want you to turn Copilot off and get some hands-on experience with Redis. So we're going to get started with Upstash Redis, and this is just going to take a few seconds. We're going to learn some basic commands and data structures, and then we're going to dive into solving some real problems in Node.js. So we're going to solve these 5 problems, and if you're just interested in 1 or 2 of these problems, that's okay. I'm going to leave timestamps on this video. But firstly, what is Redis? Well, Redis is a key value store, and it stores those keys and values in memory. This makes Redis extremely fast. But what you might not know about Redis is that it can handle lots of different data structures, and it's Redis's ability to handle lots of different data structures that makes it so powerful. So Redis actually has a lot of features that you would expect from a normal database. For example, Redis has PubSub, and we're going to see how PubSub works in Node.js later on. Redis also has transactions, which is extremely helpful. Redis also has persistence, so you could use Redis as your primary database if you wanted to. I wouldn't necessarily recommend that just because storing data in memory can become really costly. And then finally, Redis actually has programmability with Lua. So we're not going to get into persistence or Lua scripting in this video, but we are going to have a look at transactions and PubSub. So come over to upstash.com and click on this login button. I'm going to log in with GitHub. Once you're logged in, you're going to see this create database, and let's just create this database now. I'm going to call this Redis. I'm going to call this learn Redis. I'm going to set my database to global, and then I'm going to set my primary to Sydney, just because this is the closest database to me, and therefore it's just going to be a little bit faster. I'm going to enable TLS, and this just means that my traffic is going to be encrypted. And then I'm also going to enable eviction, and this just means that I'm going to evict entries when I've reached a maximum size. So let's create that database, and this will just take a few seconds. So now that my database is ready to go, I can start using this straight away. So there's a few things that I want to show you about Upstash Redis just to save you a bit of confusion. So firstly, there's several different ways that you can connect to your database. The first way that you can connect to your database is using this Redis protocol here, and you can use something like IO Redis. This is how we're going to connect to our database. This is just the typical standard connection to a Redis instance. However, with Upstash Redis, there's a second way that you can connect to your database, and this is through HTTPS. So if you come over to JavaScript, the reason that Upstash allows you to do this is because you can also use Upstash in a serverless environment and send commands to your Upstash instance over HTTPS instead of creating a connection to the instance. Okay, so the confusing part about that is going to be your credentials. So in this video, we're going to be using the Redis protocol here. And so the credentials that we're going to use are going to be this password here. So you can click to copy that password, and then you can copy this string down here that has the Redis protocol, and it also has the port number. If you're going to use JavaScript, you're going to want to use the HTTPS link. So that's going to be this one just here. This link here is your actual Redis instance. So it's fine to copy that. And then your token is not your password. Your token is down here. So you have this REST API. And so you can copy the URL from here, and you can also copy the token. So if we paste the token in the browser, you can see that that is a massive token here. Whereas if we copy the password, you can see that that's quite a short string here. Okay, so I hope that that saves you a little bit of confusion about using Upstash Redis. So what we're going to do is we're going to go over to Node, and then we're going to copy this string here. We're going to look for a file called .env. And then .env, you're going to see this Redis URL. Let's paste that in there, and then you can see that it's also copied the stars. So let's go get our password as well. So we can come up to the top here, we can copy our password, and then we can paste our password in here. So this is saying that the username is default, and then the password is this string here. So now we're ready to go. So let's have a look at the folder structure here, and I can explain what's going on. So firstly, we have this config folder, and this is just going to load your Redis URL for you. And then we have the problems and solutions folders. So the problems folder is where you're going to work, and then the solutions are going to have the final solutions. If you get stuck, you can refer to those. But I'm going to go through the solutions in this video. Okay, so let's go back to Upstash, and we can learn some basic commands or things that we can do with Redis. So if you click on this CLI here, you're going to get a nice CLI in your browser, and we can use this to send commands to our Redis instance. So let's first just set a key with a value. So we can say set, and set doesn't have to be capitalized. And we can say my key, and then we can give this a value. So our value could be a number, or it could just be a string like Tom. Now we can get this key back out with the get command, and we can say my key, and then we get our value back out. To clear the terminal here, you can just type clear, and then that is going to clear your terminal. Okay, so let's set this key again, and now let's say that we want to remove this key. So we can say delete, so del, and then we can say my key. Now if we try to get our key back out, it's nil. So you're going to see some feedback from Redis here. One is okay, and this just means that we've successfully put this key into the Redis instance. You're going to see 1, and 1 also means okay. So if you see a 0, that often means that the key doesn't exist or something else happened. It really depends what it is that you're doing. So let's clear that. Okay, so now let's say that we want to set a key that expires in 10 seconds. So we can use set x, so set with an expiry. Then we can say my key. So the next string is your actual key. The next is the seconds that you want it to live for. So we can say 10 seconds. And now we can give it a value. So we can give this a value of Tom does tech. Now let's get my key. And you can see that my key still exists. And if we keep doing this, eventually my key is going to return nil because the expiry has elapsed. Okay, so let's set another key. And I'm just going to call this key name, and I'm going to set to Tom. And let's say that we want to see if this key exists. So we can use the exists command. Now we can give this name, and we're going to get back 1 saying that this key does exist. Let's say that the key doesn't exist. So we can say name2, we're going to get back a 0, and this indicates that the key doesn't exist. When you do this in Node.js, you're going to get better values like true or false. Okay, so now let's say that we want to see all of the keys that exist in our Redis instance. We can use the keys command with an asterisk, and this is just going to tell us that name is the only key. Let's set person, and we can set this to Tom. Now let's do keys again, and you can see that we have 2 keys, name and person. Now another helpful thing to know about Redis is how to flush all of this data. So we can say flush all, and that's going to remove all of the keys. So let's do keys star again, and you can see that we now have no keys. Okay, so we've seen that we can set keys and we can perform different operations on those keys. What about if we want to use a different data set like JSON? JSON is an extremely common data set, and it's going to be extremely helpful if our database can handle JSON. And Redis can handle JSON. So let's set a user, and we can set that user to have some other properties as well, and those other properties can be in JSON. So let's say set, and I want to give this a key of users. and I want to give this user a ID of 100. And then we can use our brackets just like JavaScript object notation, and we can give this a property of name. Now we can give this a value of Tom, and let's also give this an age, and I want to set the age to 33. Now we can get our user back out, so get users and 100, and we get back JSON as we would expect. So one thing that I want to note about this is we want to treat our Redis instance kind of like an object store. So that just means that everything is lumped into one big object. And so to identify different things, we prefix our keys here with the object type or the resource type. And so I've used users here, but let's say that we had a product. We would say products, and then let's say this product had an ID of 1. Then we would give it a ID of 1 here. And so inside of the key, you have the resource type, and then you have the identifier to that one resource. So doing that is a really common practice that's going to save you a lot of headache when you're working with lots of different object types or resource types in your Redis instance. So another really common data type is hashes. And hashes are used to store objects represented by their fields and value. And to use hashes, we can use the hset command to set a hash. So I can say hset. Now I can give this a key, so users with an ID of 100. Now I want to set a property on this user of name, and I want that value to be Tom. Now we can get a property out of this hash with hget users 100, and then the property that I want to get is name, and then this is going to return Tom. Now we can set another property on this, so we can set the age, and we can set this to 33. Now we can get back our age, and it's going to return 33. So what is the difference between JSON and hashes? Well, if you use JSON, when you query by the key, you're just going to get back the whole JSON blob. When you use a hash, you can query by specific fields in that JSON. So let's clear this. So another useful data type is a set. Now a set is essentially a list, except every item in the list is unique. So we can use this with set add, so SAAD. You can remember this by sad with a D. And now we can say my set, and this is just the key, and we can set lots of different values in here. So we can say 1, 2, 3, and then we can say 4 and 4. Now we can get the set members with S members, my set, and you can see that we have 1, 2, 3, 4, even though we put 4 in twice. We can also add to an existing set, so we can say SADD, my set, and we can add a 6. Now let's try get the members back out, and you can see that 6 has been added here. If we try to add 6 again, and we get the set back out, 6 will only be there once because it needs to be unique. So let's flush all and clear. So a similar data type is a sorted set. So a sorted set is going to mean that every item inside of that set is sorted, and then you're going to be able to get them back out in a sorted order. So this is really common for things like a leaderboard, where you just want to display all of the users' top score down to the lowest score. So to do that, we can say ZADD, and we can say my set. Now we can give this a position, so we can give this a position of 1, and then we can say 1. Let's add another one, and we can give this a position of 10, and we can say 10, and then we can add one more, and we can give this a position of 3. So let's say that we want to get all of our items back out of the sorted set. We can use the Z range. Now we can say my set, and we can give this a position of 0 and -1. This is just saying that we want all of the items out of the set. And you can see that we get these back out in sorted order. Let's say that we want these in a reverse sorted order. We can do the same, but we can give this a rev command, and then this is going to reverse the list for us. Okay, so the last command that I want to show you before we jump into our projects is counters. So we can say incr, and we can say my counter. Now this is going to give us back a 1. So now let's try get this. So we can say get my counter, and then this is going to give us back a 1. Let's increment this again. And now we can get my counter, and it's back at 2. We can also decrement this counter. So I can say dec my counter, and then we get this back, it's going to be back at 1. You can also increment it by a specific value. So we can say increment by my counter, and we want to increment this by 10. Now, if we get this back, it should be at 11. We can also do the reverse and decrement it by a value. So we can say dec by my counter, and I want to decrement by 5. So if we get that, we're back at 6. So that's the basic commands that you're going to need to solve these problems. Let's go back to our editor and we can start solving some real problems with Redis inside of Node.js. So let's have a look at the first problem here. And this is the problem that everybody is interested in with Redis. And this is caching, because Redis can make your slow function calls extremely fast. So let's have a look at the problem. The fetch data function, so this function down here, is really slow and it needs to be really fast. Reduce the calls to the network and make the function faster. So essentially what we're being asked to do here is to cache the response. So we have this function here called fetch data, and I don't think that we should touch this function here. And then down in the main, we have some timers, and we're going to call this function twice. If you want to solve this problem on your own, now is a great time to pause the video, try solve the problem, and come back. So I think the best solution to this problem is to create a function called fetch with cache that we can wrap our fetch function in that is going to handle the caching for us. So let's create an async function called fetch with cache. Now this function is going to take 2 arguments. One is going to be the fetch function, and we can just type this out as type of fetch data. Now the second argument is going to be our key, and a key is just going to be a string. So the first thing that we want to do is try to get our data out of the cache. So you can see that I have a Redis instance up here ready for us to go. So we can say const cached data is equal to await client, and this is a Redis client dot get, and then we can just simply get this by the key. Now we want to say if cached data, then we want to return cached data. If we don't have the data in our cache anymore, we want to fetch the data and then set the data in the cache and then return the data. So we can say const data is equal to fetch data. Now I want to set this in the cache. So I can say await client.set. And we could set this as JSON if we wanted to, but I think the simplest version is to stringify the result and just set it as a string. So let's do that. We're going to set it as the key, and then we're going to JSON.stringify, and we're just going to stringify the data. And then finally, we can return the data. Okay, so let's go use this function here. So I can say await fetch with cache. We can pass in our fetch function. And then I just want to pass in a key of, have a look at what this function does. It just fetches a list of Pokemon. So I can set a key here of Pokemon. Now let's do this twice. And we can open up our console here. And if we have a look at the package.json, you can see that we have some scripts for running our problems and for running our solutions. And then I'm going to run this function. So you can see here that our first fetch data call took 300 milliseconds, but our second one took 24 milliseconds. This is a huge reduction in time it takes to run this function. And we didn't have to go back out to the network. So let's copy this down, and we can see this running 3 times, and then our second and third call should be just as fast. So it's really cool that we can cache data so easily in Redis, but I want to give you a little bit of a warning about caching your data. So there's several issues that can come with caching. It's not just a get out of jail free card, and you need to really consider those issues. So the first issue is that we're now storing a bunch of data in memory, and this could get really expensive. Memory storage is going to be much more expensive than, say, database storage. The other issue is that we haven't set a time to live on this data. So as long as we are not calling this flush all, then the data is going to live in our Redis instance forever. So you need to make a call about how long that data lives in the Redis instance, and that really depends on your use case. And there's several other issues with caching that you need to be aware of before you just dive in and start trying to optimize your application with caches. So let's have a look at this second problem here. And the second problem is for us to build a rate limiter. Now, if you're familiar at all with Upstash, you'll know that they have a package to do rate limiting in your serverless functions, and that is an incredibly good package. And I would recommend that you use that package or a similar package before you dive in and start building your own rate limiter. But for this example, we're going to learn more by doing it ourselves instead of just using a pre-built package. So let's have a look at the problem statement here. The do some work function is expensive to run and must be protected from abuse. So we have this function down here called do some work, and we can pretend that this does a lot of work. So we need to throw an error if the function is called more than 5 times in a 5-second window. So there's different algorithms that you can use for rate limiting, and what algorithm you use is going to depend on what it is that you're trying to achieve. We're just going to use a very simple algorithm here where we limit it by 5 times in a 5-second window. So let's have a look down the bottom here, and you can see that we're calling this do some work function 5 times, and we're going to do all of these calls all at once. So we need to protect this function here. So let's first build a function, and this is going to be an async function called rate limiter. And rate limiter is going to take a key. Now this key could be anything. It could be a user ID, it could be an IP address, it really could be anything to identify a single user making a request. Then we're going to have our max requests. So our max requests here is going to be 5. And it's going to have our window size in seconds. And again, our window size in seconds is going to be 5, but you can adjust this to test different things if you like. Okay, so let's create our key. So let's actually call this user ID. And let's create a key inside of here. So key, and I'm going to give this a prefix of rate limit. And then I'm going to give this a value of our user ID. So again, I've used this prefix here because if you have lots of different things in your Redis instance, you want to know what that particular object is for. And we're going to know that this one here is for our rate limiter. Let's say that we had a document for users, we would prefix that with users, and then we might have a rate limit object and a user object, both having the same ID, and adding this prefix just saves us from collisions there. Okay, so to do this, we're going to need to use a concept called transactions. So to do that, we can use the multi function. So let's say const current is equal to client, and we need to await this actually, client dot multi. Now we need to execute multi. And then we can call dot increment, and we can increment our key. And now we can set an expiry on this incrementer. So expire. And I want to expire this in window size in seconds. And now we just need to execute this transaction. So .exe. Okay, so what are we doing here? Well, firstly, we're just starting a transaction with multi. Then we're going to increment a specific key. Then we're going to say, hey, this key should expire in this many seconds. And then we're going to get the result of that. So if we hover over this, you can see that it returns this really funky type here. What it's doing is it's returning an array for each one of the steps inside of the transaction. So we just need to test that the current value has a value. So we can say if not current or current dot length is equal to 0. then I just want to return false. So if we return false from this function, it means that our rate limiter has failed and we should throw an error for the user. Okay, so now let's iterate over our current. So let I is equal to 0, I is less than current dot length, and then I plus plus. And we just want to check that there's nothing in the one value. So if current, and we want to get the ith value, and 0, then I want to return false. So this is a little bit weird, but essentially what we're doing is we're checking in the 0th value to see if there's an error in there. So if we have a look at the type again, you can see in the 0th value here, there's going to be an error in that position. If there's an error in any of the positions, then we just want to return false, and we can actually log out the error. So console.error, and we can say Redis error, and I want to console.log current, the ith value, and then the 0th value. Okay, so now we need to check if the rate limit was exceeded. So I can say const request count is equal to current 0 and 1. So we're getting the 1 position because remember in the 0 position is going to be an error. And then this is going to be a number, and we need to typecast that to a number because Redis doesn't really know that, or at least IO Redis doesn't know how to infer that. So we can say if request count is greater than max requests, and max requests, remember, comes from the function arguments, then this means that we have exceeded our rate limit. So we can return false. Otherwise, we can just return true. So we could simplify this here into one line, but I think being nice and explicit is a good idea in this case. Okay, so do some work is going to be responsible for handling its own rate limit. You could make a wrapper function, say called function with rate limiter, like we did in the previous challenge, but I think it's okay for do some work to handle its own rate limit here, just so I can show you how the rate limiter works. Okay, so the rate limiter is going to return a Boolean value, and we're going to call that Boolean value success. So if we get a true value, it means that we're good to proceed. So we can say const success is equal to await rate limiter. Now we can pass in a key here, and this is just going to be some user. Again, you can use whatever key you want. It could be an IP address, a user ID, whatever. So we want to give this the maximum number of requests. So I'm going to say 5, and then the window size is going to be 5. So we're going to say if not success, then we're going to throw a new error. And then this error is going to say rate limit exceeded. Otherwise, we're just going to return a string that says success. So now our function down here to test it, what are we going to expect? So let's increase this to say 10. So I expect the first half of these requests here to succeed, and then I expect the second half of these requests to fail. So let's open up a terminal, and we can find the command for this. This is going to be problems rate limiter. So pnpm problems rate limiter. And let's have a look at the output here. So the first 5 here succeed, and then the second 5 fail. So we can actually run this again by saving the file, and you can see that we get the same output. So if we run it a few times, you can see that we're going to get the same output every single time. The reason for that is because at the top of the file here, we're going to flush all. So we're starting with a clean surface every single time that we run this file. So the third challenge is going to involve PubSub. Now, this is one of my favorite features of Redis. It is so powerful, especially if you're working in a microsystems architecture, or if you just need to publish messages around different services, or even if you're creating a chat application or scaling something horizontally. There is so many use cases for Redis PubSub, and it's extremely simple to get started with as well. So let's have a look at the problem statement here. When a user sends a message, we need to publish that message out to other systems. The other systems are all connected to the same Redis server. So I actually have a video on this, and in that video, we create a chat application that scales horizontally and uses WebSockets, and it's all connected via Redis Pubs Hub. And I'll link to that in the description below, and I'll also link to it in the README. That video is also sponsored by Upstash, and I think that's an incredible intro to using Pubs Hub to scale something horizontally. So to do this, we need to create two instances of Redis. We need to create one for the subscriber, and we also need to create one for the publisher. So let's say const publish client is equal to new Redis. And then we're going to have our Redis URL. Say const subscriber client is equal to new Redis. And again, this is going to take our Redis URL. So let's also create a constant for our channel name. So I can say const channel name is just going to be my channel. Okay, because we're using this in multiple places, it's a good idea to have a constant. So the first thing that we want to do is we want to subscribe to messages on this channel. Now we're going to do this all in one file, but you can pretend that the subscriber lives on one server and then the publisher lives on a different server. So let's say subscriber client dot subscribe. Now the channel that we want to subscribe to is going to be our constant of channel name. Now we want to have a callback here, and inside of this callback, we're going to have an error. And if we do get an error, so if error, then I just want to console.log or console.error, and I want to log failed to subscribe, and then we can just add the error here as well. We don't ever expect to see this value here. I've been writing go too much, so I wrote instead of error. Okay, so now we're subscribed to the channel. We want to start listening to messages on that channel. So I want to say subscriber client dot on. Now we can give this a string and we want to say message. You can see there's lots of different strings you can give this here. The one that we want is message. And again, this takes a callback. Inside of that callback, we get our channel. So what channel did we receive this message on? And we also get the message. So this channel here is important. Let's say that we had a chat applications and we're sending messages on a channel. We'd want to prefix this with chat and then my channel name. So let's say that we had a live leaderboard and we're publishing messages out to a client. We would want to use a different prefix here like leaderboard. So I'm going to leave this prefix here just to remind you, you should always be prefixing these channel names and prefixing your keys. And now we just want to console.log our channel and message. So console.log got message, and we can put in our message on channel, and now we can put in our channel name. So that's our subscriber done. Let's start publishing messages to this channel. Now I want to publish messages on an increment of say every 2000 seconds. So I'm just going to set an interval. Now this interval takes a callback, and then it also takes a number, and this is the milliseconds that we want to publish this message. So I'm just going to say 2000, and this means that it's going to publish a new message every 2000 milliseconds. And let's move our publisher client down so we can see all of this together. Now I can say publisher client dot publish. Now I want to publish to my channel. Actually, that's going to be channel name. And then I just want to publish a message. So I can say hello from publisher. And first, what are we expecting to happen here? So we're subscribing to the channel, and then every time we get a message on that channel, I'm going to log out that message. So every 2 seconds, I expect to see this message here. So let's test that, PM. And you can see, got message from publisher. We got it again. Let's also add a timestamp here. So we can say new date. We can save that. Now we also get our timestamp here, and you can see the timestamp is changing by 2 seconds every single time. So it might be hard to imagine why this pub sub is useful. So I'll give you an example of how I've used this in a previous company. So we had a microservice architecture, and in one service, we were producing events. And we wanted these events to be published out to a user interface. So what we did is the user interface talked to a GraphQL server, and that GraphQL server was listening to a Redis instance. And when it got that Redis instance, it published out to its subscriber, and that went out to the client. So we published the message from the server that was producing the events. The GraphQL server would listen to those events, and then it would publish out to the client. So that is just one of many ways that you can use Redis PubSub. Okay, so let's move on to our fourth problem. And if you've made it this far, congratulations. You probably know more about Redis now than a lot of other developers. So thank you for sticking around. So in this problem, we're going to store users in JSON format with their ID as the key. We now need to write a function to fetch a user by the email. So let's have a think about what the issue here is. So we need to store them in JSON format. So we can't use our hash function because when we get the user, we need to get the whole user. You could do this with a hash function, but that's not the solution that I had in mind. So we're going to store the user by their ID, but we also want to be able to get them by their email address. So if we have a think about how a regular database would do this. So if you insert a bunch of users into a database, you can then query those users by their email address. But straight out of the box, that's going to be really slow. How you can speed that up is by using indexes. And if we have a think about what an index is, essentially it is just a key value pair. So you're going to have a key, and the key is going to be the user's email address, and then the value is going to be the ID. You can then do another lookup from there. So essentially what we want to do is to create an index. So we have this array here, and this array is just creating 10 users for us, all with an ID, a name, and an email address. Now we need to insert these users, and then we need to find the user by the email address. So we need to fill out this function here. And then we're going to call our find user by email, and we want to log how long this took. So let's call client.hset. So we're going to be setting JSON, and I want to set a key here of users, and I want to use the user.id. And then I just want to set the value of user. Okay, so we have all of our users in the database. A naive approach to this would be to get all of those users back out, look through that list of users, find the one with the email and return it. But that's going to be really slow. We can be a little bit more clever. What we can do is now we can set an index. So I can say client.set. And because we know we want to look them up by email, we can say users. And we can call this email IDX. And this just signifies that it's a index of email on the user's document. Now we can give this a key of user.email. Now the value needs to be the user ID. So user.id. It might be tempting to store the whole user object in here, but what we want to do is we want to reference back to this user object. So if we change this object here, we can still use this index. Okay, so now we need to get our index back out. So I'm going to say const index is going to be await client.get, and we want to get this value here. So let's copy that. And we just want to use the email address. And let's actually call this user ID. So now that we have the user ID, we can get the user back out of the hash. So I can say const user is equal to await client.hgetAll. We want to get them by the user ID, but we set the user ID like this. So let's copy that. And now we can replace this string here with user ID. And then we can just return the user. So let's go to our package.json. And we can copy the command here to run this. And we can run pnpm problems find by. And you can see that we found the user document here by this user1 at example.com, and this took 200 milliseconds. So the final thing that I want to show you is transactions in Redis, because these work a little bit different to how a regular database would handle transactions. So you don't have a rollback, for example, because Redis is focused on performance, and that would really hinder performance. So we have this example here where we're going to set a value of should fail, and we're just going to set that to a string of integer. Then we're going to use the client.multi. So this just means that we can start queuing up some tasks for Redis to execute. So Redis is going to guarantee that it executes these tasks in order altogether. So we're going to queue up the first task here to set a key and a value of 1. We're going to set up the second task, and this is going to increment our string. So this one here is going to fail, and then our third task here is just going to set another key. Then finally, we're going to execute this pipeline. So let's go to the terminal and have a look at how this is going to work. So you can see here, we get value 1. So this is value 1, and it's actually been set to value 1. We get value 2, and this has been set again to value 2. Then we get should fail, and this is not an integer. So it did fail, it didn't execute, it didn't increment this value here, it just remained as the last value. So this is going to work differently to how you might expect regular transactions to work, but transactions in Redis are really helpful when you want to queue up several tasks to be executed all together in a synchronous way. So that's the basics of Redis. I really hope you can walk away from this video and be confident that you can recommend where Redis should be used and how it should be used. Thanks again to Upstash for sponsoring this video. And if you liked this video, please let me know in the comment section below how you plan to use Redis, and make sure you leave a thumbs up. Thank you for watching, and I will see you in the next video. Thank you for watching, and I'll see you in the next video.